Good morning. It's Saturday, April the 5th. I said yesterday was the 3rd, but it's actually the 4th. So that makes today the 5th. Just going to show you these castable refractory setups that I've poured yesterday. I started off with this one here. This is the 24-inch and a quarter titanium pipe, and that was set on top of the funnel, so it has a little bit of a bevel there, and that's exactly what I wanted. So when this is threaded into the air pipe, you're going to have a complete seal, but I'm going to still have to make a swirl device for it, probably, to restrict the air. So that was my number one piece. Then I went and I casted one of these. I just had it on the table. I didn't have it on top of the funnel here, because I wasn't planning to make all 5 of these. That turned out good. I actually brought them in last night and cleaned them up while the castable was still a little bit wet. And this is a piece of heavy brass, same diameter as the titanium there. And last night I had this cast inside like this. Oh, knocked the piece out. Still hasn't hardened up hard. But anyway, I brought this in last night so I could actually pull this out before it's set up. So the castable, you have about a 5-inch piece of castable in there. And the reason for this is going to be a resonance test to try to trigger a level 2 and a level 3 burn. So this is threaded into the air. This would go over the back like this. And you'd be able to adjust the depth of this pipe, the center pipe, to, I don't know if you can see inside there or not, but you can see the center pipe is just a little bit in from the base of the refractory. So that's where your level 2 should happen within the 1-inch pipe, and from the outside you should get a level 3. So I'll be able to adjust the resonance, because you're going to get 2,000 signatures in this, and this might be the trigger to opening up the superstate. That's the reason for that test. Okay. This is the castable. I wasn't planning on doing it. It's a little bit off-centered, but it's good. This is your 16-inch stainless steel, and I've already got the stainless to where it can actually burn imprints on the inside of the pipe. But with the castable, once it's dry and all that, it's going to hold in the heat. So the exhaust temperature coming out of here should be at least several hundred degrees or more hotter. So you're talking about the melting point or beyond the melting point of the stainless. So it's going to be interesting to see. So the test I'm going to do with this, once this refractor is all cured, is heat this up and just hold a piece of copper on the end, and it should instantly, just from the exhaust itself with no flame, turn it molten. Okay, now let's give you a little demonstration of what it's like to put this in. So I'm going to have to pan over here. So I have to take a wire brush and wire brush the threads clean. This is where the Joepipe fits in now, or before. So just change out the fitting. See if we can, I haven't tried fitting these yet. Well, there you have it. Should work for a very, very good seal. I don't have to worry about the heat. You make a little swirl device to go on the inside, because by itself, the way it is now, it's you need that air reduction to make it work proper, for whatever reason. And I like to take some soapstone next and make a little swirl device where the center is in the shape of a horn, and so the outside edges will be rounded off. But basically, you want to try to generate more vacuum in the center, and still allow a little bit of airflow to come on the outside. And so I want to make it small enough where I can wrap it with stainless steel wire, number 19 wire, right? Try to duplicate these swirl devices I have now, and if there is a implosion flame being generated, increasing the vacuum should increase the spin, which should increase the heat. Just like Brown's gas, Brown's gas will melt or vaporize anything known, and so this is showing Brown's gas properties because of the vacuum. Then we can say that we do have some kind of shift into the monoatomic state from the molecular state. That's what brown gas is. It's not a molecular fuel, it's a monoatomic fuel. It's H1. We get H2 going back into H1, and it generates very, very hot heats. Okay, that's it. So just give you a view once more. Isn't that beautiful? And it didn't take long, maybe an hour to make all this stuff. Just one of those spur of the moment things. Beautiful piece of work. They're perfectly centered, but that's alright. Okay, gonna cut it here.